Let's go over the rules for significant figures. Number 1, all non-zero digits are considered significant. So in any number, if you have something like 2,467, this is going to have 4 significant figures. If we have the number 2,300, the 2 and the 3 are significant because all non-zero digits are automatically significant. And rule number 2, we're basically talking about any trapped zeros. So when you have trapped zeros, meaning that you have zeros bounded by non-zero digits, then it's going to make those zeros significant as well. So here the number 23,001, the 2 and the 3 and the 1, of course, are significant because they are non-zero digits. These zeros right here, they are trapped between the 3 and the 1, which makes that also significant. So right now we have 5 significant figures in this number. Rule number 3, zeros to the right of a whole number or to the left of a number in decimal expansions less than 1 are not significant. So if we take a look at a number like 1,000, 1,000 is going to have one significant figure. If we take a look at a number like 0.0023, this is going to have 2 significant figures. So all of these leading zeros are not significant, and all of these trailing zeros are not significant. Now, if we go to rule number 4, notice the number 2.30 is actually going to have 3 significant figures. Once you have non-zero digits, and there's a 0 at the end after a decimal point, there has got to be a reason why we add that there. Maybe the number was 2.29876 blah blah blah, and you want to round to 3 significant figures. Well, in this case, it's going to either be 2.29, or because the number next to it is bigger than 5, then we have to go up. And so we have to go up to 2.30. Let's look at example 1.1. Round the number 10.562 to the nearest whole number. To the nearest whole number, this is going to either be 10 or 11. Because it's 10.5, then that means that this to the nearest whole number is going to be 11. The second one says to 2 decimal places. You're only rounding to 2 decimal places. So you take a look at 10.56. It's either going to stay 10.56 or become 10.57. The number next to the 6 is 2, so it's going to stay 10.56. Then for the third one, 3 significant figures, we're going to keep the 1, the 0, and then we're going to keep that 5 or make the 5 a 6. So it's either going to stay 10.5 or become 10.6. In this case, because the number next to the 5 is greater than 5, it's going to become 10.6. In part B, when you are completing the table, first you have to identify for each one of those numbers how many significant figures it has. Notice the first one has these trailing zeros, so that's going to have 3 significant figures. 0.006 is going to have 1. 0.3052 is going to have 4. 40.00560, every single digit there is going to be significant. So that's 2, 4, 6, 7 significant figures. The second part of the question is to take each one of these numbers and then round to the given amount of significant figures. The first one, 25,400 to 2 significant figures is going to be 25,000. The next one, to 1 significant figure, it's going to just stay the same. 0.3052 to 3 significant figures will be 0.305. And 4 significant figures here means it's going to be 40.01. In this case, we have these 4, but you always have to look at the number next to it. And because it's 5, that's how I know that I have to round up to 40.01. Hope you found this video helpful. Remember to subscribe to my channel for more help with math so that you can say, yes, I can do math with confidence. Until next time, thanks for watching.